Okay, in this video, we are going to be discussing partial fraction decomposition, and this is a pre-calculus topic. And the reason for this is because when you get to calculus, you're going to be talking about something called integration, and partial fraction decomposition can be useful in integration methods. So let's go ahead and talk about partial fraction decomp. All right. So what we have here is we have a fraction 2x plus 3 over x plus 6 times x minus 3. So there were two fractions. Suppose the first one we'll call a, and the second one we'll call b, all right, because these are linear terms in the denominator. So the denominator of the first a, let's say, is x plus 6, and the second one is going to be x minus 3. So what we're going to do is figure out, well, what are these a and b values such that when I add these two fractions, I get 2x plus 3 over x minus 6 times x minus 3. And it's actually x minus 6 now that I think about it in my example. Not x plus 6, x minus 6. Okay, so let me correct that. All right, so what we're going to do here is we're going to multiply everything by the denominator to eliminate the denominator. So I'm going to put the parenthesis around there, and I'm going to multiply everything by an x minus 6 and an x minus 3. There we go. I distribute that across the board all the way across. So what that does is it eliminates the denominator completely in the first fraction there. All right. Over here on the other side, I eliminate the x minus 6, leaving me with an a times x minus 3. And then when I multiply it by the last part of the fraction there, b over x minus 3, I eliminate the x minus 3's, leaving me with b times x minus 6. Okay, so I've done that. All right, there's really nothing to it. All right. The next thing that I'm going to kind of do, there's a couple of ways that you can approach this. We'll approach this with the systems method, okay? You can use a systems of equation to solve this. So let's suppose that we distribute the a, all right? And we're going to distribute that across the way there. So 2x plus 3 equal, let's say ax minus 3a, and we distribute the b. We're going to get bx minus 6b. All right, so now what we're going to do is we're going to say, okay, well, the 2x plus 3 corresponds to x minus 3. I'm sorry. We look at the x components. ax plus bx, all right, watch this, minus 3a minus 6b. All right, we just regrouped, and now we're going to factor out the common factors. So 2x plus 3 equals a factor of x out. All right, so we'll factor the x out, but first we're going to write a plus b multiplied by x. And then in the next part, we really don't need to factor out. We're just going to leave it as negative 3a minus 6b. So this is, again, one way of solving this. All right. There's another method, and I can go over that one as well. All right, so this is what it looks like. Okay, the a plus bx corresponds to the 2, so we create a system here. A plus b equals 2. All right, that's the first equation. And then the second is that negative 3a minus 6b corresponds to the positive 3. So what we're doing is we're matching this with this, and then this with this, and that's how we're coming up with these equations. Okay, so really at the end of the day, there's nothing to it. We just what we could do here is some elimination. So let's say I multiply this by 3. What does this yield? Well, this yields 3a plus 3b equals 6, and we have a negative 3a minus 6b equals 3. And then we combine the two equations. We get a negative 3b equals 9. So we end up with b equals a negative 3. All right, so I now have b equal negative 3. And I can go back to the original, a plus b equals 2. And I can say, okay, well, a plus, in this case, negative 3 equals 2. So I'm going to add 3 to both sides. And I get that a equals 5. So my decomposition tells me that my fractions are going to be 5 over x minus 6 plus a negative 3 over x minus 3. So this right here is my partial fraction decomposition. And I'm going to go ahead and take a look at this one other way. And this one may be easier. All right. So let's see what we've got here. We've got, and I'll write this in a different color. Suppose I write it in blue. We've got 2x plus 3 equals a times x minus 3 plus b times x minus 6. So our job here is going to be substitute in a value for x. So in the first case, I'm going to pick x equals 3 because it's just a wise choice to make. And you'll see why in a second. If x equals 3, I have 2 times 3 plus 3 equals a times 3 minus 3. You should start seeing why I picked 3. 3 minus 6, b times 3 minus 6. Well, I picked x equal 3 because x minus 3 will set this a term to be 0. And this leaves me with 2 times 3, which is 6, plus 3, which is 9, equal 2. And then this is a negative 3, negative 3b. All right. So here I can say, well, b just equals negative 3. All right. There's my b. And then I pick another value for x, and I'm going to pick x equal positive 6. And you'll see why in a minute. 2 times 6 plus 3 equals a times 6 minus 3 plus b times 6 minus 6. Again, now you see it. It eliminates the b term. So what do we have here? We have 2 times 6, which is 12 plus 3, 15 equals 6 minus 3 is 3. So 3a. And a equals a positive 5. And again, this brings us to the same conclusion back over here. So again, a couple of different ways that you can do this partial fraction decomposition. But otherwise, this is a good pre-calculus review. If you're in pre-calculus, great. If you're in calculus, a good review when you get into integration of rational functions by partial fractions. So as always, I hope this video was helpful. And remember, like and subscribe.